We're now going to move on to operators. This will just be an introduction, as operators is quite a large subject. Operators in Python are symbols which indicate some form of computation will be carried out. This could be arithmetic computations such as adding, subtracting variables. It could be comparisons type computations, so checking whether something is equal to something or not equal to something, or other types of computation. You'll be using operators throughout your programming experience, so this will be a key topic to discuss. Going forward, I will revisit operators and cover it in a later stage in our lessons. So I'll begin with arithmetic operators. So I'll use this hash symbol. This basically just tells Python that this is a comment. So if you run the code, as in I'll choose the green triangle, nothing will happen. So arithmetic operators are the following. So you have a plus operator, a minus operator, a division operator, exponentiation one, integer division, and the modulo operator. So I'll describe them here. So you have a variable, an integer of value 10, and another integer with value 20, and you set a third integer equal to a plus b. Here plus is the plus operator, and a and b are the operands. These are the operands of the operator, and the result is assigned to c. So what it will do is kind of what you would naturally expect it to do. It'll take the variable a and add b to it, and if we print the result out, you get the result that you would expect. So a is 10, b is 20, and if you add them together you'll get 30. Here we're using variables, but you could also just have literal numbers here as well. So here you would have a equals 10 plus 10, so you'd get 20 as a result. You could even have both operands as literals as follows. So you get 30 as expected. So I'll change it back to using variables. The minus operator, again, acts as you would expect. So here we're taking a and we're minus b. And if we run this, we get minus 10, which you would expect. You then have the division operator. So here you'll be taking a and dividing by b, so you get half. So if we run this, you get half. Notice that the answer's converted to a floating point. This would occur even if the result was an integer. So if we had 20 divided by 20, even though the answer is an integer of 1, you still get it as a floating point. The exponential operator basically puts it to the power of the right hand side operator. So here we're saying a to the power b, which is to the power 20. This is quite a large power, so we'll just move it to power 2. So here we're saying a times a, which is a squared, which gives you 100. If b was 3, it would be a to the power 3, which is a cubed, which would give you 1000. We'll now cover the integer division. So the integer division, what it will give you is the result of the operand b, how many times it will go into the operand a as an integer division. So for example, if we was to run this, 3 goes into 10 3 times, it will leave a remainder of 1. So for integer division, the result will be 3. To get the 1, which is the remainder, use the modulo operator. So b, which is 3 into 10, goes 3 times, and you end up with a remainder 1, and modulus will give you that result. So you end up with a 1. You also have a multiplication arithmetic operator. I'll give you an example. So here we have variable A and variable B, and we're multiplying them together, and you get the result 6. You also have augmented assignment operators, which I'll discuss now. So for example, say you had A equals 10 and you wanted to carry out the computation as follows: A equal to A plus 1. We'll print the result out. You'll be taking A, which is 10, adding 1 to it, and then reassigning it back to A. So when we print this out, you'll get 11 as expected. Well, a shorthand for this is simply to use an augmented assignment operator as follows, which is plus equals, which is basically adds the 1 to the A and then reassigns it back to A. So that's the shorthand for what you've just seen. It could be 2. So here you're taking A, which is 10, adding 2 to it, and then reassigning it back to A as we print out A. So the augmented assignment operators apply to each of the above arithmetic operators. So you have the following augmented assignments. Just for a few examples, I'll show you. So we had the minus augmented operator, assignment operator. You would here be taking 2 away from A and then reassigning it back to A. So you end up with 8. You could have the division. So you're taking 10 divided by 2, then reassigning it back, so you would end up with 5. So that applies to all the other arithmetic operators. You also have a multiplication augmented assignment operator. I'll show you an example. So here you have a integer variable, which is then multiplied by 2 and then reassigned to itself. It should be noted that in the examples up to now for arithmetic operators, I've just been using integers, but the float type of numbers with decimal points can equally be used with all these arithmetic operators. For example, you could create a number such as the following, and another one, and you could apply the plus to the variables A and B, just as we did for integers. So when we output this, you just get the 2 variables added together. Equally, all the other arithmetic operators as division, integer division and exponentiation can equally be applied. Here we're applying integer division. We actually get the result 0 here because 3 goes 0 times into 1, and then when you apply the modulo operator, you get the remainder of 1.12. Another thing to point out is, although there's a priority order in which Python will apply operators, you can make things more clearer for using brackets. So for example, exponentiation takes priority over addition. So when we run the following code, B is squared and then A is added to it. But you could make this a bit more clearer, just for using brackets to indicate the squaring is carried out first before the addition. And you can add even more complexity to your calculations through adding further brackets as follows. So now the squaring takes place first, you add A, and then finally you divide by 2. So I'd definitely recommend using brackets to make clearer the order in which calculations are being applied. The augmented assignment operators also can equally be applied to the float types of numbers. So I'll just give you an example. So I enter two float variables for the floating type of integers, floating type of numbers, and we can apply the following augmented assignment operator. Here is the addition augmented assignment operator. Let's correct this. So we've got the b variable that has a value 3.2222, and then we're adding 1.1111 and then reassigning it back to the b. You could actually use the a variable instead of a literal number, and here you're just adding the a variable to the b variable and then reassigning it back to b. All the other arithmetic augmented assignment operators equally apply. So here we're taking a from b and then reassigning it back to b. Here we're dividing b by a and then reassigning it back to b. In the next lesson, I'll be covering comparison operators.